Matrix or inverse method of solving simultaneous equation. That's what we are looking at in this lesson. And we are looking at 3 by 3 equation, that is third order equation. So equations, 3 equations in 3 unknown, like this example. And how do you proceed? First make the matrix the coefficient of the unknown matrix of their own. So you have, let's say P is the matrix of the element. P is equal to the coefficient of the x, y, and z. Coefficient of x here is 1, coefficient of y is 1, coefficient of z is 1, coefficient of x is 2, coefficient of y is minus 3, coefficient of z is minus 1. Coefficient of x here is 3, coefficient of y here is 2, coefficient of z is minus 3. Is equal to x, y, z. The unknown that we are looking for should be equal to the equation 2 minus 1 minus 27. Then P inverse, don't forget that the inverse of the matrix, to use inverse or matrix method to solve a simultaneous equation, you need to first get the inverse. And you recall from our previous lessons that inverse of a matrix, that's P inverse, inverse of this matrix, is adjoint of P over determinant of P. Adjoint of P, ADJ P over this P. That's adjoint of P over determinant of P. And if you do your determinant of this matrix correctly, your determinant, that's P, that determinant of P, should be equal to 32. Now, how do you get the adjoint also? If you don't know how I got this 32, you can check my previous lesson on determinant of a matrix, third order determinant of a matrix. I use two methods. We have Cramer's rule and Saru's rule. And I use the two methods to find determinant of 3 order matrix, that 3 by 3 matrix. So you can check how the determinant of this one is 32. And also the adjoint of P, which is ADJP now. ADJP should be equal to, if done correctly, 14, 6 to 5 minus 7, 3, 13, 1 minus 5. So this is the adjoint of the matrix. We've also learned adjoint in this lesson. So you can check how I arrive at these solutions. Then if I proceed from here now, the inverse will be adjoint over determinant. That is my P inverse now, which is adjoint, which is this one over determinant. That will be 1 over 32. Then into the matrix itself now, which is 14 to the adjoint, 14, 6, 2, 5 minus 7, 3, 13, 1 minus 5. So if I continue with this now, if I use this inverse to multiply by the answer, it will give me my x, y, z. Multiply this inverse by this answer to give x, y, z by this one. That is my x, y, z should be equal to 1 over 32, which is my x, y, z will be equal to 1 over 32, which is the inverse 14, 6, 2, 5 minus 7, 3, 13, 1 minus 5 times multiplied by the answer, which is 2 minus 1 minus 27. So if I multiply this by this now to give my x, y, z, so in that case you have x, y, and z should be equal to, this will time this time this, that's 28. This time this is minus 6, and this time this is minus 2 times 27 minus 54. So if I add together 28 minus 6 minus 54 is equal to 32. So this will give me minus 32 here. Then the same thing with this second one. This time this is 10. This time this is plus 7. And this time this 27 times 3. That's plus, that's minus 81. So you have 10 plus 7 minus 81. That will give me minus 64. So this is minus 64 here. This one should be equal to 1 over 32. This one is still there. Then the last one, this multiplied by this, that will give me 26 minus 1. Then you have 27 times 5. That will give me plus 135 minus 1 plus 26. That's 108. This will give me 108. So all this divided by 32 now, I will have the value of my x. So this will be x, y, z is equal to minus 32 divided by 32. That will give me minus 1. 64 divided by 32, that will give me minus 2. 108 divided by 32. Let me check this again. This time this, that's 26 minus 1 plus, well, 2. So this is minus 4. So you have minus 4 times 27. That's 108. So you have 26 minus 1 plus 108. Minus 1 plus 26. So you have 133. So if we continue with this, this will be 13 times 2, that's 26. Okay, this is 3 minus 5 now. 26, 1 times this, that's 1 times 1, that's minus 1. Then 5 times 27, that's 135 plus 135. So 135 minus 1 plus 26, that gives me 160 divided by 32. So you have 160 divided by 32, that's 5. Therefore, so you can now write in this place, therefore, our s is minus 1, y is minus 2, then z is 5. So this is how you use inverse or matrix method to solve simultaneous equation. So this is an example of using matrix or inverse method of solving simultaneous equation. So we continue in our next lesson.